we're talking about attacking back-end components, and quite a bit of this is stuff you've already done. So the simplest thing is command injection, which is where I started because I think it's by far the simplest security problem to exploit. And this, I think, the fundamental reason why you have SQL injection and command injection vulnerabilities is that you mix two languages together. If you just had a C program and everything you did was done by C, then not much of this would happen. You'd have other things like buffer overflows. But here, it is quite common to write code that instead of doing something, creates a statement which is then passed to some other system, which then parses it, as if it had been typed in by a human, and that's what leads to command injection vulnerabilities. So in Perl, you can do it here with this command thing, with just the apostrophe here is command, where it prints the command. It's going to execute this command, creates this variable, and then runs it as a shell command, which is asking for it. So if you have the application is CGI, so you call it from a browser, and it has a parameter which is supposed to be a directory. So if you put in the name of a directory, like public, you get a list of the files in that directory. That's using the thing as intended, but since they did it by just creating a command that's going to do dir followed by whatever you put there, then you can put in public and then a pipe, and then cat x password and get the password. You can use a pipe, a semicolon, a variety of things to separate commands. And you can even take something that is not expecting any input and put a pipe before it, and then Unix will what a pipe does is create a temporary file, then feed the results into the next command. But commands won't crash just because you feed an input they're not using. They'll just carry on and do it anyway. So it's a way to tie things together. And in case you think this is unrealistic, it happens all the time. I mean, it's not like every product is vulnerable to command injection, but there's enough that there are ones out there. And here's HP OpenView had a command injection, and as you know, you've done it in the projects, that graphics library, ImageMagick, had command injection vulnerability, and that one's kind of entertaining. That one caused the City College firewall to determine that the students in the lab were attacking a site, and that site was attacking the college by reading the instructions. And now it's got my site flagged as hosting malware on 4 malware detectors, because they wait until the thing is 6 months and over, and then they're so stupid they can't tell a page about the exploit from the exploit. So it's kind of interesting. I think it serves as an instructive bit of information about which antivirus companies are too stupid to deal with. And a lot of them are too stupid to be in this business. I mean, when Vincent Treviso is the main sheriff here, he goes and finds antivirus products and tears them apart and reveals who should really just give up and go home, and quite a few of them should. There are real tests of antivirus, and people ask me often what the best antivirus is, and the things I know are the Microsoft products are completely useless, and they've admitted that. The best is always Kaspersky. I mean, they had the top-notch research, and Nod32 is pretty good too, and the stuff like Norton and McAfee is like a B. It's not bad, but it's not as powerful as like Kaspersky, and the free stuff is like a C. And even the best will only stop like 5% of the attacks now, so it's pretty pathetic. But it is amazing how the rest of them just steal their stuff from Kaspersky, and Kaspersky has humiliated them over and over. Kaspersky seems to be doing most of the work in the business. Anyway, so then ASP, of course, has the same option. You can make a process that's going to launch, and here's going to start a process that's going to do a command C dir name, so it's doing the same thing as the last one. It's going to do a dir on a name that comes in, and I know you can do it with PowerShell. Every language has this ability because it's super convenient to write a program to just call a shell to do something like a ping or an HTTP request or something, but it's really dangerous. If you're going to do this, you really better scrub that data before you pass it on to some other language. And I think doing this is kind of the clue that you're not a very good programmer. You don't really know your language enough to do what you need, so you go to some other language, which you probably don't really know either, and that's how you end up in this madness where you leave a wide door open. Anyway, so there's this opening a directory, and so you can inject other commands, and here this thing is a web page like the one you did where you put the name in there, and then you say show contents, and it will show the contents of the directory, and in there you just put ampersand ipconfig, and it will then do ipconfig after showing the contents of some default directory. So anyway, that's the game. Here's the one I use, PHP. You can use eval or various other commands which are the kind of things that are deprecated. People prefer you not to use these. There's a list of 3 or 4 commands that do just execute system commands, and they say don't use them. Just like if you use C, they say don't use sprintf and things like. There's a list of 4 or 5 commands that are responsible for most of the vulnerabilities. All right. So if you want to find these things, any item of user-controlled data may be used to create a command. You might be able to guess from the structure of the app which ones are going to do it, but you can just feed in special characters followed by commands that do something and see what happens. Backtick is a big one. You can do immediate evaluation in a Unix command line. So I'm going to need my Linux machine anyway. Let me get it going here. So real developers tend to do it this way. I don't know why. So if I want to do like, I think of an example. See what I've got. Okay, I've got examples, test results. Let's go into here. All right, so I've got a file here called HTTP. Okay, it's just a file. We'll be playing with it later. So I could do an ls of ht star. All right, and I could do an echo of ht star. Echo of ht star. Okay, and that echoes this. So you can have a command that evaluates inside another. So I can do ls of backtick echo ht star. And what the backtick will do is evaluate this command immediately and then feed the output of it into the next to be used as the parameter. So that'll now do the ls of ht star. And one thing I learned from Georgia Weidman's book, this backtick thing gives everyone a headache. It's hard to see, it's hard to type. And so there's another way that's equivalent to do it, which is much better if you're going to be printing instructions and such, which is this way, which is the way I always like doing it. It causes less trouble. It amounts to the same thing. So what's inside there is evaluated and then fed in, and then you run as if you had typed it in. But anyway, that's a handy way to stick in a command. If you have some kind of structure, like it's going to do dir, and then your input, and then .htm or something, you're in the middle of something where you can't just put in whatever you want, you could use this kind of backtick stuff or dollars to inject a whole other command in the middle of something, which would then evaluate. And so that's,
I don't know if eval is the correct phrase for it, because there is actually an eval command in Linux.
There is.
And that actually creates a subshell. So I don't know if eval is the correct word for it. I wouldn't use it at all, because there's actually an eval command.
Yeah.
And if you're going to say that's
so I can do eval.
Eval.
So I can do eval of echo hi.
Oh, there's no space there.
And yeah, now it tries.
You can put a space between the echo and hi.
I didn't. I think good. That's right. Okay, good. Let's do that. Yeah. All right. All right. And error near unexpected token echo. I don't know. I don't know how to use eval. Maybe that's not how you use it. I don't know about a command line eval command. What's that? Man eval. Yeah, man eval. Yeah. I'm always too lazy for that. See that here. Eval arg in. So just this. No apostrophes. Okay. Eval echo hi. And it creates Amazon. Okay, that's my mouse. All right, now it creates higher. I need something that's kind of less crazy. So if I do date, that'll work. But if I do this, it should complain because it's now trying to execute mon something. Mm-hmm. So if I do eval of date, it doesn't do that. Well, you got to play with it and learn. Anyway, so that's different, and I'm not. Yeah, there's certainly a difference, and it's good to know these versions because any one of them might be the one you need. Anyway, then what's fun is blind command injection, just like blind SQL injection. Suppose you cannot see the output of your command, especially since you're injecting some other command that was not intended by the developer. They might be finding a name and then printing out a name, and you're trying to do an if config or something, and you can't get it into the name, so you can't see the result. So one thing is to create a back channel if you find some way to make a network connection someplace, like make an FTP connection to a controller you, or an HTTP request to a server you control. But if you can't figure that out, you can just use ping to create a time delay. So here's one with NSLOOKUP. So you're going to do NSLOOKUP and then put it in some file that's executable. You could put your script code in there. It will then store in that file the error message, and the error message will include the script code, and then you execute that file and execute the script. This is a pretty common trick. Versions of this, like you put something in a log file and then execute the log file, and you sneak commands in there. It's a common way to achieve code execution on boxes that don't appear to offer code execution. And I've got your next project. You got a few of these to play with, so let me bring them up here. Here, attack. All right, so this old thing, I've added another thing here called blind vulnerabilities. And so it's sort of fun to play with. So here's a simple one just to ping google.com. So test it, and I wrote it so it doesn't even print out the results, doesn't even show you the pings, it does this. And I printed out the command, which is just so you can see what's going on. It does ping twice of google.com, then it greps for the phrase byte from, then it counts how many lines there are, and it puts it in this file called temp.net and then if that number is bigger than 1, it prints OK. So it doesn't actually print the results of any of those commands on the page. So you can't see what you're doing. So here's one way to do it. This is the side channel solution, where what you do, I want to do an ls. And if I just go here, like you did in the very early one, and just do ls, I can run it, and it did the ls, but I don't think I see the results of the ls. Although they might be in here someplace. I don't think they are, because the ls is actually pretty big on this server. And this one is really pretty sleazy. You can even see the results of the ping. But anyway, it's hard to see the ls. So what you do is you don't just put in ls, you put in this, ls to a file I can see. Now I probably already made the one using your name. You can use each file only once. So let's make this your name 2. All right. This is going to do the ls and put it in there. And then it's going to foul up the syntax and probably mess up the rest of this thing. But it is going to run before that happens. So it created this command that pings something, then puts an ls in there, then does a grep on something and decides it fails. But it did create this file called yourname2.htm. And if I go up here and put attack/that mess, that's where the ls is. So that's one side channel. Put it in a file you can see somewhere. Execute an FTP command and send it up to an FTP server that's under your control or something like that. Some way, move the data off to the site. But if you don't have that option, you really have to use timing. And I tried to write one here where you really have to use timing. If you find some dirty trick to get in without it, then you'll find it, that's another way through. But so here's a goal. I'm going to try to find out if a file named temp flag exists. So here's an injection to try. If I do this one, and let's make it your name 4, and run it, then it removed the greater than sign. Less than and greater than signs are filtered out. So this doesn't work. It's not going to create a your name 4 file, and if I go look for it, it's not going to be there. So I'm not allowed to use that kind of back channel. And there might be others you can use, but the thing I want to do here is just go right to the real-time delay one. So here's the game. Here's one which will do it. So this is going to look for a file called temp flag. And what it does, this is the inline bash. So if this condition is true, it will then do ping something 10 times. Otherwise, it'll not ping something 10 times. So if I put in a simple thing here, well, we'll just do both cases. So this is a file that doesn't exist, temp flag. So if I run it, 1, 2, 3 seconds, and it comes back. So it didn't do any 10 pings, because that would have taken 10 seconds. So the file does not exist. And if I want to verify that it's true, I can use this netok file, which is one created by the previous one. So I know there's a file called netok, and that verifies that I'm not just fooling myself here. If the file is there, then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it really does take 10 seconds if the file is there, and 3 seconds if the file is not there. And that is the goal. So you can now ask yes or no questions, like 20 questions. You can pump things out. So I gave you a series of challenges here, and let me just point you to the project. In case you haven't done this before, if you don't know any programming at all, I thought I'd at least get to this point. Most of you will probably find this easy, and especially if you take my other class. But the first thing is to automate some requests. Now you could actually do this one by hand. So let me just show you that if you don't know any programming at all, you can still do like 2A. So there's a file in this folder with a 1-digit file name between 0 and 9. So you just have to modify this to look in user local secret. So I can see if this is user local secret /0. And it'll be fast if it's not there. 1, 2, 3, it's not there. So you can try them one by one, even without programming. And that will work here. So that one you can do, find that file. This one, you have a 3-digit file name. And I don't think you're probably going to have patience to do that. Although, to be fair, there are smart ways and dumb ways to do it. And let me point out this one here, one way to do it, which I highly don't recommend, is this way. Look for 000, 1, 2, okay, it's not there. Then do 001. You could do it. It'll take 1,000 requests. But there really is no need to be like that. I mean, this is standard directory. You can do 0, question, and find out 1 digit at a time. So it's only going to take 30 requests. Even that is kind of a lot if you're typing them in one by one. And to encourage you to move beyond that, I put one here that's 9 digits long. So that's going to take 1 billion requests, or it's going to take 9 times 1090 requests. And both of those are hopefully tedious enough that they'll motivate you to write a script. And it occurred to me I ought to just put in how to write the script. So here's the project I gave you, automated web request. If you haven't done this, it is a very good thing to know how to do. I'll just do it down here. And there are many ways to do it. One thing I found is that the Firefox developer tools stink. They don't let you see the raw request. They see the process stuff, and you'd have to rebuild it out of chunks, and that's for the birds. So I use Wireshark. So you put Wireshark on here, which totally lets you see what's going on. You have to run sudo. The new version of Wireshark actually has some option to turn on some special features so you won't have to be the administrator, which totally doesn't work. You still have to be the administrator all the time. The Wireshark is one of the funnier products because every time you run Wireshark, it says, quit running me as administrator. And every time you don't run it as administrator, it can't see it in the interfaces and you can't do anything. So it's like, you know, in case you're interested, no one should use this product at all. Now let's carry on. Anyway. And it is, they're not kidding, by the way. There are exploits that will take over your machine through Wireshark. So anyway, it always says, don't run Wireshark as administrator. What are you, an idiot? I say, yeah, I'm an idiot. So anyway. So I start sniffing. I'm on a natted virtual machine here, so there really is no traffic, so I can just let that sniffing go for a while. Now I open this page here. All right, so I want to find out, let's start with the 1-digit one. So if I want to do if user local secret, okay. Whoops, I want to get rid of that. That's what I tried to use, it didn't work. Maybe it's Control-C, I don't know what the copy and paste key is and wire in this environment. Let's see, Control-V. It is Control-C and Control-V. All right, so I'm going to put in user local secret 0, then ping. And if I do it, it's 1, 2, 3, and so it's not there. And I want to automate that. So you go to Wireshark, stop sniffing, and go to HTTP. This is a very powerful technique, although the problem is HTTPS is a little bit trickier. And I'll just mention, if you want to do an HTTPS website, which you had to do in CTFs, the simple solution is just set up burp to proxy HTTPS to HTTP, and then continue to write your script to make HTTP. That way you don't have to bother with the encryption. There are fancier ways, but I found that to be quite simple. Burp can do the SSL strip attack. It's pretty easy. Anyway, so now I filtered for HTTP, so here's what happens. I have post. This is one of the greatest things about Wireshark. If you click on an HTTP request, and then you can then do analyze, follow TCP stream, and it throws away all the addressing and just shows you the layer 7 data right here. So this is what you want to send. And so this is the post command. Let me make it big as I can if I can get this thing to move. Anyway, this is the post command that created it, and it is kind of a mess. Let me get out of here. All right. So you have a post, then you have target equals google.com. Here's the injection with user local secret. A bunch of the characters have been URL encoded. It's got pluses instead of spaces. So, you know, it's kind of a mess. I could build it myself out of pieces, but I don't, why bother? You just highlight in Wireshark, then you copy it. Now you just go to a text editor and make it. So this is like so easy, it'll make you sick. Make another window. Shift-Control-N will make another window. And then I can use LeafPad, because I realize there's no reason to be so cruel as I was in my other class. You can actually use like a graphical environment. The student is always clicking and nano and getting frustrated. And if you're going to be a hacker, you got to learn how to use command line only environments. But you don't really need it for this class. So you just paste in that junk. So there's the request I want to send. And this thing is like Notepad. You can use the mouse, which will make people happy, I think. So, all right. I got to make my window bigger. This is not big enough to see what I'm doing. All right. And I wonder if I can double click a title bar to make window big. Neat. All right. And it's still not big enough, which is irritating. Oh, because of my projector. And I don't see how to scroll. All right. Well, there's the orange bar. Good. All right. So I can drag this thing to the left. Come on. All right. So there's the request. Now to send a request, all you need to add is a little bit of Python around here. Request equals quote, quote, quote. The cool thing about triple quotes is you can have multi-line things in there. So that's the request, straight out of Wireshark. Now all I have to do is open the socket. So I make it executable, user local, user bin, env Python. Now that's all I really need to have up there. Now, there are many ways to make HTTP requests, but if you just want to send the raw text, I just use the socket library. So import socket, and then s equals socket.socket. This will create a socket object, and then s.connect, and you put the URL here. Now, one thing to note, by the way, is when I did it here in class, I used attack.samsclass.info, which is HTTPS. If you want to get rid of the HTTPS, I made an insecure version on my website just for this reason, which is attackdirect.samsclass.info. So that's a way to avoid the bother of having to deal with HTTPS, which is another nuisance. So you put in the name of the server, and then the port 80, and you need 2 sets of parentheses because for some reason they wrote the connect method not to take 2 parameters, but to take 1 parameter, which is a tuple. So it means we need 2 layers of parentheses. And now you can do s.send request, and then print the result, s.receive. 1024 bytes of result up to that, and that's it, s.close. Now, unless I forgot something, which I might very well have, that should be it. So save this. And if you click in there, I should grow a toolbar up here. You have to point up here for the toolbar to appear, which frustrates a lot of students. They're looking for the toolbar down here because they use Windows. You have to go up there to find it. This is a strange mixture of the worst of the Mac plus the worst of the PC that Ubuntu has chosen for their desktop, which is what they usually do. So save that thing. This is HTTP1, and now you can run that thing. Let's see if I have a unused window. I do. Right, that one I'm done with. All right, so ls shows that I have this thing called HTTP1. It's not green because it's not executable. You got to make it executable. So mod plus x, HTTP1, and then /HTTP1. And it works. It sent the request. It got the reply. The reply contains a header I can read, but the actual contents of the body, I can't read them, and that's because the request I captured was from a real browser, and real browsers allow it to zip the answer, which is something you want to save bandwidth to make your browser respond faster, but I don't want it for my text-based browser because I want to see what's going on, so I just need to get rid of that line. Don't zip the junk. So I have to modify my program up here, accept the coding gzip inflate, deflate. Just forget it. Let's not accept that. You just take it away, and the default is to just send me real text. So now save that, and now run it again. And now I get stuff I can read. So this is the time-based, this is just the HTTP that led to that other thing. And of course, the interesting thing is the time it takes to respond. And you could do it one by one. And I didn't put the instructions in the project, but I thought I'd demonstrate it here because it's really very easy. So now I'd like to know how long it took. And I like to put in a loop. So to upgrade this thing to something that will automatically try a group of them, I need to do 2 things. I need to vary this stuff here, user local secret 0. I need to vary that thing there to go through a loop, 0, 1, 2, 3, 4. And I need to record the time. So to do that, the simplest thing is cut this in half, make this request 2, and make this request 1. So now it's 1, and then 2, and get rid of that 0. Okay. So now down here, before I send anything, I'm going to make request equals request 1 plus string of I plus request 2. That's the string, and then you'll send the request and get the answer. And here I have to do a loop. So for I in range of 10, that'll go from 0 to 9. In Python, you use indentation to see how big a loop is. So I send it and print the answer, and that's it. Then close when it's all over. So this will now do all 10 of them and print out the results. Did I screw it up? What's up? What should be request? Oh, yeah, I should. Thank you. Good. That's a G instead of a Q. Good. All right.
In the beginning.
Oh, good. Okay. All right. Good. So that'll do it. But the problem is I didn't keep track of the time.
And s.send should be s.send r instead of r.
What's that?
Right below, line below. Right
Oh, that one. That's a Q. It should be a Q.
But it should be
R.
Oh, it should be R. I think. Good. Good. You guys are on it. Great. All right. So now that'll send it and print the results, but I won't have the time. So to get the time, I need to bring in the time library. And then before each request, I need to record what the time is. T0 equals time.time, which will give me the Unix epoch in seconds. And then afterwards, I'm going to get the receive. I'm going to say rec equals s.receive sub 1024 to make sure I've waited until it really happened. And then I'm going to let dt equals time.time minus t0. That'll be the time elapsed that it took to do it. And now I'm just going to print, I don't really care about the response, I just care about I and dt. There. That's what, so now it'll do it, it'll keep track of how long it took, and it'll try all 10, unless I fouled it up, which is entirely possible. So let's see what that one does. That is going to be this one here, there. And it looks like it's working. So it takes 1 second, most of the time, and this one's taking a lot longer. And if you want it to be efficient, you might not use 10 pings, but maybe 3 pings, or even just 2 more pings, you know. There, that one took 9 seconds, the others took 1 second, so you can see which one is the standout. And you can modify this to try digit after digit until it always turns to all, and that beats the hell out of doing them one by one. But anyway, that's the kind of thing, and that's what you should do. That's blind injection, where all you have is a time delay, and you have to make yes/no questions. And like you see in the textbook, they would often show you take the first letter of the username of the administrator. Is it A? Is it B? Is it C? Ask a series of questions that will eventually trace out what you want to know that way.
There are also a couple like blind injection frameworks on GitHub.
Yeah,
So
yeah, that's good. And I know SQL Map can do it for SQL injection. And I'm not sure about command injection, but anyway, that's what I wanted to show you there. And certainly it's a thing you should know how to do. It'll be quite easy for you folks that know any programming. And even if you don't know any programming, you can probably figure that much out. You don't really need to know much of anything to do Python. You just need a couple of examples and a lot of queries in Google to server fault every time you get stuck. That's how I do it. That's pretty much how everybody does it. You just copy a few lines from server fault. The most important thing when you're a beginning programmer is to not write more than a couple lines at a time. Write a couple lines and test it. Write a couple lines and test it. Because if you write a whole page, you'll get 6 errors and you'll be lost. But if you only write a couple lines, you know the mistake is in those lines. Anyway, all right. So if you want to prevent this stuff, the best practice is not to be like this. Don't mix 2 languages together. What are you, a wimp anyway? Why don't you just read your manual and learn how to do things in whatever language you're using? That would be the best answer. But of course, everyone's always under time pressure, and it's so much easier to do it the other way that half of my stuff is written that way, like everybody else. Yeah.
I don't know, like at least from my experience, a lot of people will tell you like, you know, don't invent the bicycle, just use something that somebody already created.
Yeah.
So when you have a multiple modular project, a
Yeah.
lot of time you just have to use written by somebody else.
Yes, that's often the case. Yeah, that's a good point. Anyway, so if you have to do this, then filter the input with whitelisting and filter the output with whitelisting. Whitelisting is the best practice. Blacklisting is where you try to list all the bad characters and remove them, and that is just a challenge to the hackers to find some way to encode the bad character to sneak through your filter. Whitelisting is much better. You only accept things from a known list of good characters. All right, and using APIs is a lot better than creating a line of code that's going to be parsed at the other end. The parsing is what really gets you in trouble, where it tries to match up apostrophes and such, and that makes it easy to confuse it into doing regarding text as data, text as commands. Anyway, so you shouldn't pass user input into these things if you can avoid it. If you have to, filter it with whitelisting. And then there's file path traversal. So if you have a file name or directory name somewhere, then the user can inject parameter characters into that will make it point to somewhere else than where you want it to go. So here's a thing that shows a file in the browser, and a lot of websites are this way. They have a PHP thing or an ASP or whatever this is, and then they have a file name. Instead of just referring to the file name directly in the HTTP request, they pass it in as a parameter, and then some function fetches the file, and therefore it's just begging for us to put in a path instead of that name. So here's Windows win.ini, which is sort of like the ets.password. This will see if we can actually point outside of the web-served part of the file system over into the system part of the file system and print out the contents. And if you can, you'll see a Windows system file. So you might be able to read files like that, or you might be able to write to files, because maybe you're doing like an image upload for a profile or something, and you're able to specify the name of the image, and you're able to put in characters to specify the path to the image, and now you can write things on arbitrary files. This is the simplest way you deface web pages, add text to a page, replace a page with a mocking image, and so on. So you might be able to modify things. You might even be able to modify security critical things like configuration files and software binaries, kill the firewall, change the firewall settings. So you might want to monitor your file system. Your book mentions a tool called FileMon, which was deprecated years ago. It's now replaced by Procmon, which is a Windows tool you can run to monitor the file system. The problem with Procmon is you cannot leave it on all the time. it's like Wireshark. It builds up a ton of data really fast. So if what you have to do is turn it on, then do something like run a virus you're analyzing, then turn it off. If you want to have something on all the time to see what files people are making, it's Tripwire, like you've done in the project. So Tripwire you can have on your machine all the time, and it can scan it every day or something, give you a list of what's changed, and that's a lot more practical. And at least that way you'll find out if some clown is overwriting files through your vulnerable code. If you want to detect this stuff, you're testing a machine, just inject a unique string in each parameter, and then filter the file system monitoring tool to see if there are any requests going into the file system using that string. And so here's a successful path traversal attack. This is a quite common one. This is that Windows win.ini. The file name is just .. .. By the way, it's recommended to try both the forward and backward slashes. Windows is supposed to be using backward slashes, but it will often take forward slashes. And so just try them both. And sometimes one will be filtered and the other isn't. And so that's the contents of that file. I don't know why it's got all this MPEG video in it, but I don't really know what's in a win.ini file anymore. Win.ini file hasn't really served any purpose since MS-DOS, but it remains around like an appendix, so it's a file you can point to and read. So you might try URL encoding your stuff to get past filters. So a dot is %2e, and the slash is %2f, and the other slash is %5c. So you can put those in, and maybe they'll pass filtering because they're not literally equal to the forbidden character at the first stage. You can try 16-bit Unicode encoding with %u. You can then try double URL encoding. This is specifically an attack that worked against IIS-4 because they decanonicalized it twice. So you would take a %252e, and the %25 would turn into a %, and then it would be %2e, and then it would turn into a special character, dot or slash. You can try long Unicode. Unicode actually can be as long as you want, so that it will expand even beyond 16 bits to 32 bits and 24 bits for languages that may have even more characters, like Japanese and Chinese have versions of it like 30,000 characters. And so you can put in things that are really long. And what's interesting about this overlong Unicode encoding is that it's technically wrong, but a lot of people write code that will accept it. They're technically legal, but they're accepted by Windows Unicode representations elsewhere. And now it's really a funny combination of characters that the person writing the filter didn't anticipate. That's why whitelisting is much better, because there are so many screwy ways to encode things. You're not going to think of them all. And then, of course, the one we did last time where you can, if they filter out .. slash, you can put in something that will turn into .. slash after removing .. slash, because they probably didn't think to do it twice or 3 times or whatever. But they really need to do it like a while loop. Well, as long as there's .. slash, keep taking away .. slash, but they're unlikely to think of that. All right, and then you can put null characters in. This is cute. You often have a thing that limits your file name extension. Like if you're going to upload a file, it'll only take JPEGs or GIFs. It might even automatically add a JPG to the end of the name you type in, so you don't get to specify the file extension. So one cool thing there is just put in a null byte. That will cause the code to regard this as having the right extension, but when you refer to the file later, like you browse to it in a browser that was written in C, this will terminate the string. So you put up something that's going to be interpreted as an ini, even though another part of the system thinks it's a JPEG. This is cute, and I remember about 5 years ago, there was a DEF CON, there's a Pony of the Year contest at DEF CON, or Black Hat, where you would attend greatest exploits. And one of the greatest exploits was JIFAR, because it's either one, I don't know if I'm going to get forward or backward. A jar has a header but no footer, and a GIF has a footer but no header. So you can make a file that is a GIF and a jar, and they're both valid. And then you can upload it, and it looks like an image, and you can just browse to it and execute it as Java. And it's completely legal, and it fouls up this whole system of trying to sort files by their file name extension or even by their contents. That was a cute one. There was a similar one long ago called Bubble Boy, where a rich text format was considered to be as safe as text. Text is considered safe, and rich text format has some formatting characters, but no one thought you could program it, and Bubble Boy virus was the guy that figured out how to make executable code in a rich text format file. So all the people that thought they were preventing you from executing code, it was able to execute code anyway. And this tends to happen. Anyway, so if you only have read access, you can look for password files for the OS and apps, configuration files, include files. Include files typically contain database credentials. I mean, most people the sleazy type, they just hard code the credentials right in SQL statements. But if you are too professional for that, you put them in a directory with limited permissions, and then you include that file so the credentials come in. But if you can browse to it and read it, then you can find the credentials in there. Look for database files, source code for scripts, to hunt for bugs or to find hard-coded credentials, log files, and so on. You know, if you can read things on the box, there's usually a lot of goodies to browse around and find. I remember this was one thing that happened to the guys in Rochester. They said they found a server all full of credentials. They even found the user manual for the administrator that said every time a new user joins the company, put their credentials in this spreadsheet. Like, all you do is find that spreadsheet. That's asking for it. But a lot of people, they had a policy like that at one of my jobs. Anyway, all right. So if you have write access, and you want to write executable code, you could write a startup script in somebody else's folder, and then next time they log in, it'll run. That's pretty cute. There's a book called Silence in the Wire someone talked to me about. This is a fantastic book, although it's actually incredibly impractical. Silence in the Wire is a book written by how much damage could you do without sending any packets at all to the server. And he found a lot of great things you can do. And one of the great ones is you want to attack some site, so you make a bunch of links that point to your target.com, and you put them on some other site, like a link that's target.com / followed by my attack. But I don't do it. I don't do the attack. I just put the link on my page. Now you wait for Google to crawl your page. They will click the links. Google will attack that page for you. Put the results in the Google cache. I go look in the Google cache later. There's no trace back to me. And people really did this after that book came out. There's this awesome stuff. And that's the game here. I'll just put my script in this other guy's startup folder. Next week he'll log in and they'll fire him for hacking a server, and I'm sitting pretty. Anyway, so an in.ftpd is a file that is used to create a new server-side version of something when you make an FTP connection. Just like if you look in the Apache, if you look in the process listing for Apache, it's creating a new process for every user. So if you make each FTP connection uses this file to launch the server side, so that's cool. Make that. Then when someone connects to the FTP server, it'll run my malware. So that's pretty cute. Anyway, and of course the thing we did with all the PHP shells, you make a script and then call it from your browser. Now that's fine, but you are sending a packet straight from you to them to execute the attack, so it's not incredibly stealthy, although it doesn't appear in a bash history log or anything. Anyway, so if you want to prevent these things, of course, the same old thing, don't pass user-controlled data into a file system API. If you have to, then limit them with only a list of known good inputs. If they have to submit file names, then there's a series of defenses you can put in. If you're going to be letting them type in their own file name, which you might be letting them do because it's part of your system where they can put up some files and download them. So after you decode and decanonicalize them, you get them to order, then check for forward slashes, backslashes, null bytes. If you find anything bad, don't clean it and use it. Just stop and say, quit sending me crap and send me a reasonable file name, because it's very likely that whoever is trying to attack you has also anticipated your next step. And use a hard-coded list of permissions, printed file types, and reject any request for a different type. These are good practices. All right. Make sure that the file name is okay and that it exists in the directory if it's a read. There are ways to do this. In Java, there's a thing called get canonical path, and in ASP.NET, there's get full path, so you can browse to the file, get the file system's automatically generated path to the file, and then compare it to the path you got from the user and see if they match. And they won't match if they're doing something funny, like / or null bytes, and if they don't match, just throw them back and say, knock it off and just give me a plain file name that works. You can also run your app in a chroot jail. This is cute. Long before there were virtual machines, there was chroot. Chroot is where you take a folder and you call it root, and then you put applications in the folder, like Apache and whatever else you're using, and it runs a copy in there, and it can only refer to files in that folder and subfolders. There's no path that leads out of that to the real file system. They call it a jail. Your app is running in this jail. You put in the app and all its dependencies in there, and nothing they can do can break out of the jail. There are some attacks if you have root access to break out of a chroot jail, but otherwise it acts like a poor man's virtual machine. They're trapped in this little subsection, and all your important stuff is over here. Simple sandboxing. You can do the same thing in Windows. You can map a drive letter to a folder. The folder can be down in the file system, like C, inetpub www-root maps to D, and now all my stuff is hard-coded to use drive D, and drive D can only go to that folder and subfolders. You can't point out to C. So that amounts to the same thing, essentially. And of course, your defenses against all these things should be connected to your logging alert. If you get anything like people putting null bytes in the file name, you should be putting that in as an alert to your alert system. This is obviously, we're under attack. We should think about blocking this IP address and logging it and all that jazz. Then there's file inclusion. Now, are we talking about you have to include files all the time? You include credential files, you include library files, you write your own libraries and include them everywhere. So every piece of code has a bunch of files that are brought in from elsewhere. And you can often trick the include function into including files that shouldn't be in there. And that's the point here. So in PHP, for example, one thing people commonly do is to specify the country in a parameter, and then it will go fetch some file from countrycode.php, which will have all the special currency marks and everything else they need to handle that country. So if they do it this way with something that came from the user, then I can specify something evil here. The country equals HTTP backdoor, and now it will include the backdoor, where it includes them elsewhere. There's local file inclusion and remote file inclusion. Local file inclusion is where you browse on the server itself and include a file, and some people filter out this HTTP either intentionally or by accident, just by choosing the methods they call not supporting that, so you cannot refer to something off the server, which you can only do local file inclusion. This is remote file inclusion, where you take some file from some totally different server and stick it in and execute it, which is really handy. This is how you put malware on sites. It's one of the simple ways. Now you can have just malware hosted somewhere else. It's included in your files. It's served up to your users. You're going to end up on the blacklists. And if you scan your own file system, you won't find the malware. The malware is being added from an external site with these remote file inclusions. All right. If you want to find these things, try injecting these things, a URL on the web server you control, and then look at your own server logs and see if you're able to get files that are being fetched by the target. Go to a non-existent IP address. You'll see a time delay as it tries many tries and timeouts to connect to this thing it can't connect to. And if it's vulnerable, you can put a malicious script on the server and see if it executes, like a script that then calls off to does something you can see, like uploads a file or sends a signal to some server you control. Then try known executable, known static resource on the server. Try to see if you get sensitive resources, get to other folders, usual stuff. You wander around and see where you can get with this thing. All right, I got a few eye clickers, and then we'll take a break. All right. Not that many today. You'll probably all win. We'll see. I got in at like 3 o'clock last night, so I didn't have as much strength to write as many eye clickers as usual. Every time I get an SFO after BART is closed, I just end up wandering around like a fool. Can't find my way out of the damn airports anywhere. I finally ended up like 5 blocks away somewhere and got some Uber guy to pick me up. There's some place you're supposed to go to get Lyft, and I can never find it.
A specific place? I took Uber. Well, you're supposed to do the departures, so.
But I can't find departures. I go to the BART station, it's closed, and there's no way to get to the right level.
The international apartment, Alan did the same thing. He went downstairs. It's just, you just walk out the first door. You don't see the doors when you're there. You see an escalator going down.
Yeah.
You just walk past that escalator and go outside.
Yeah, well, I ended up in a
You can't see the
garage.
doorways.
I went out the garage, ended up walking around some alley, and eventually found some place with an
You
address.
go on autopilot where you're just heading towards baggage
Yeah,
claim or
I
whatever,
know, that's the
and
problem.
Then you're in where you can't go.
Yeah.
But as soon as you get off the plane, you just walk like out these doors. They're
Yeah.
between big plants.
I should have
so
waited for
gotta-
you guys.
Yeah.
I thought I knew what I was doing, but I wandered around like a fool getting lost. Anyway, all right, so which vulnerability lets you add malware from another server to a target web page, which is pretty rude. Now, to be fair, the most popular way to do this and most effective is to just buy an ad. And then it loads ad for another server. That's the way they're built. That's why there's usually a very simple way to get your goal that doesn't involve any real sort of hacking at all. But anyway, all right, I'll quit at 1:40 here, I think. The answers are in. All right, and that's remote file inclusion, so it's C. All right, good. All right. All right, which defense puts the web server in a restricted file system? All right, good. That's your root. All right. really old school. Same guy told me about Chroot also told me about tar pits. Tar pits are a really nasty thing. What you do is you program it to take forever to respond to every request. Like send, then you delay 10 seconds. Then act, then they type one character, delay 10 seconds. One more character. This is one way to slow down attacks and people that annoy you. He did that to punish people who were like trying to exploit his server. He just throw you on a tar pit and then you're miserable. Anyway, all right. Which one is a defense that detects file system modifications? All right, I guess I'll quit at 25. Yeah, it looks like the answer is random. All right, and that is procmon. No longer filemon, procmon. All right, so let's take a break until 7:25, then we'll finish this up. I'll stop this recording.